Hi, hello everyone. So we've talked about this before, but I'm going to put it into as good a video as I possibly can. So we're going to have a look at binary numbers again, and we're going to see well, what are they all about. So at the moment, we're used to these numbers. Okay, and those numbers, as you are aware, are called either denary, decimal, or more officially base 10, because they're based off 10 digits. Okay, simple as that. We use it for our everyday life. We didn't always use it. Okay, we didn't always use it. We used to use imperials, which was revolved around base 8 and base 12, and in the olden days we used base 60. So there's lots of different systems out there. We use base 10 because, well, it's easy. You've got 10 fingers, 10 toes. It's an easy one to kind of do. Binary, as we know, only uses a 1 and a 0. Okay, so binary is called binary, or more officially, base 2 math. Okay, so let's do the comparisons. I suppose we'll start off with that. 0 in binary is okay. So 0 in binary is 0 in denary. Okay, 1 in binary is 1. Now, this is where it gets crazy. 2 is 1 0. 3 is 1 1. 4 is, well, you guessed it, 1 0 0. And 5 is 101. 6 is, what is it again? 110. 7 is, you're getting the idea. 7 is 111. And then 8 is 1000. I always remember that one. And then so forth and so forth and so forth. Okay, until you get to 15, which is 1111. And that's your first nibble full. Okay, remember we talked about this in the previous video. One nibble has 16 possible combinations of ones and zeros. There are 16 possible combinations from 0 to 15. Okay, so I suppose the crazy thing is how does 0 become 1 and 3 become 1 1? Okay, right, it's not too hard to figure out. If we're doing base 2, then everything is going to be in base 2. So first of all, let's just have a look at base 10. Okay, so let's have a look at the number 3243. Okay, if I was to ask you to rewrite that as the sum of powers of 10, because that's what you are doing in base 10, well then, let's start with this. Let's break it down. You would have done this as in primary school. So I know my kids have been doing it recently. 3243 is 3000 plus 200 plus 40 plus 3. Okay, 3000 is 3 times 1000. 200 is 2 times 100. 40 is 4 times 10. And then 3 is 3 times 1. Now, have a look. 10,000, or sorry, 1,000, that's 3 times 10 to the power of 3. That's 2 times 10 to the power of 2. That's 4 times 10 to the power of 1. And that's 3 times 10 to the power of 0. Do you see that? This is this when I convert it into base 10. Okay, so now let's take the same number and let's see how to do it. Okay, I wonder, is it easier? No, it's actually, we'll park that example and we're going to see how I can convert from binary to base 10 and then how to do it backwards. Okay, I suppose that's probably the easiest way of doing it. Okay, so I'll come back to this just to show you in a few minutes, but I want to get as easy as possible. So how do we do it? Okay, so let's pick a number. 10111011. Okay, what is that? This is how easy it is. Step 1, draw a table. Step 2, 1, 2, 4, 8, 16, 32, 64, 128. You might need to go further, you might not. It all depends. Okay, you can decide that when you get there. Okay, but this is the important bit. Line up your number over your grid. Okay, it's important. 1, 1, 0, 1, 1, 1, 0, 1. Okay, so once you have it lined up, this is a really cool bit. Okay, you're only going to add the things that have a green 1 over them, or whatever color you put the ones. So I'd put 1, 2, not putting the 4 to 0. Okay, I'm putting the 8, I'm putting the 16, I'm putting the 32, not putting that, and I'm putting the 128. So I'm going to add up everything I see here. 128 plus 32 plus 16 plus 8 plus 3, 187. So that is 187. Okay. Now, you might think I have a better way of doing this. That's fine if you have a better way of doing it, but I think this is foolproof. You can't argue with it. It is what it is. Okay. We'll do it again. Okay. We'll do it with another number. Okay. 1, 1, 1, 0, 0, 1, 1, 1. Okay. So we're going to find out what this is. First, I'm going to count how many there is. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of them. So that means I need at least 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 4, 8, 16, 32, 64, 128. Okay. So let's try and work it out. Put the number over it, starting on this side. 1, 1, 1, 0, 0, 1, 1, 1. So the only ones that are the ones that are not going to carry down are these two. So put zeros there. Everything else is going to be add 128 plus 64 plus 32 plus 4 plus 2 plus 1. Okay, so that's 128 plus 664 plus 32 plus 7, 231. Okay, hope you've noticed something. If it has a 1, what do we know? If it has a 1, it's odd. If it has a 1, it's odd. Isn't that funny? If it has a 1, it's odd. Okay? They're odd numbers. So, now, is there another way of doing this? Of course, there's another way of doing this. Okay, so I'll show you another way of doing it if you really want to. Okay, 1, 0, 0, 1, 1. You just put the power of 2 over the ones that have a 1, starting at the power of 0. 2 to the power of 0. So I'm going to add these 3. Use on the calculator. 2 to the power of 4 plus 2 to the power of 1 plus 2 to the power of 0. 19. Okay? So that's another way of doing it. Now, if you're not 100% honors maths happy and confident, I would do it this way. This will get you the answer, and no one with you on the planet. Okay? If you are very confident, you can do it this way. Okay? It's just it. Okay? So, if you think about it, up to, if you have an 8-bit we've talked about this already. An 8-bit number has 256 possible combinations, but it actually only encodes the numbers 0 to 255, because remember, we're starting at 0, we're not starting at 1. Okay, and do you notice that that's a theme throughout this whole course? Remember when we're doing Python and we're looking at indexes, the indexes start at 0 and they don't start at 1. See, these things are all kind of linked into each other. It's really cool. So obviously an 8-bit number can only go from 0 to 255, whereas a 16-bit number can go from 0 to take one away, 65535, something like that. And then a 32-bit number can go from 0 right up to 4,294,967,295. You know, it can get big. So that's a 32-bit number, can get that many digits out of it. You know, so how do we work backwards? I suppose that's the tough one. How do we work backwards? For me, the easiest way to work backwards is to take a number. Let's take a number. We'll take the number we had at the very start. Where is it? It was, yeah, here it was. It was 3243. Okay, take the number you had at the start. It's probably the easiest way to go. Okay. So 3243. It's a big number. You can see that. So draw your table. Okay. This is very important. Okay. We'll start with whatever 1, 2, 4, 8, 16, 32, 64, 128. We're going to have to go past it because it's a big number. 128, 256, 512, 1024, 20, what is it, 48, yeah, 2048, and 4096. Right. Now, this is the important thing. Very important. What you do is, and you're going to need a calculator for this. Okay. What you do is you go up to the number that's just smaller than the one you have. So I'm not going to go to 4096. I'm going to 2048. Okay. And what I'm really going to say to myself is this. Okay. This is going to be a 1. Why? Because 3243 minus will give me a positive number. Okay, so watch. 3243 minus 2048, okay, is 1195. And that's key. Okay, now you check, will 1195, if I take it away from that, give me another positive number? It will. 1195 minus 1024 is 171. So there's another 1 in there. Now check it here. Will 1171 take away 512? No. It won't give me a positive number. No, won't give me a positive number. Yes. Here's my next one. 171 minus 128 is 43. So that gave me a positive number. Will that give me a positive number? 43 subtract 64? No. Will this? Yes. 43 subtract 32 gives me 11. Will this? No. Will this? 11 subtract 8 gives me 3. Will this? No. Will this? That's important. Yes. 3 subtract 2 gives me 1. Now, we're left with a little problem at the last one. We've got 1. What does 1 subtract 1 give me? 0. Okay. Oh, sorry. 1 subtract 1 gives me 0. So what's left? There's 1 left. What am I thinking of? Yeah, it has to be odd. Okay. If it was Yeah. If it was 2 subtract 2, it'd be 1, and then 0 left. 0 to subtract, it gives you 0. So that'd be it. We'll do one with even now in a second just to show you. Okay, so it looks very complicated, but that's your answer. Your answer is 1 1 0 0 1 0 1 0 1 0 1 1. Now we can always check that that's right. Let's check that that's right. So that's 2 to the 0, 2 to the 1, 2 to the 3, 2 to the 5, 2 to the 7, 2 to the 10, and 2 to the 11. Let's check. 2 to the power of 11 plus 2 to the power of 10 plus 2 to the power of 7 plus 2 to the power of 5 plus 8 plus 2 plus 1. There it is. Okay. Now, we'll do the exact same one, but we're going to do 3242. Okay. So, same thing. We're going to do 3242. Okay. So, 3242. So, I'm already predicting that the last one should be a 0. So, let's do 3242. So, listen, at least I know how many I need to go up to, so I can do it a little bit quicker. 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and then I need one more, 2048. Okay, so we can do this pretty quickly now. So there's going to be a 1 here. So take those two away from each other. 3242 minus 2048 is 1194. That means there's going to be a 1 here. Take away that, 1024. I get 170. No. Yeah, 170 minus 128, 42. No. Yes. 10. No. Yes. 2. No. Now, here it comes. So we're down here. We've got 2 left. 2 take away 2. Okay. So 2 take away 2 is going to be 0. So you're putting a 1. Okay. And 0 take away 1 is a 0. So the question is this right? Okay. And that's mean you can check it in a couple of seconds. So I'm going to be adding, that's 2 to the 0, 2 to the 1, 2 to the 3, 2 to the 5, 2 to the 7, 2 to the 10. It's nearly the same, and 2 to the 11. Okay, so 2 to the power of 11 plus 2 to the power of 10 plus 2 to the 7 and 2 to the 5 plus 8 plus 2. It is. That's so cool. Okay. Now, I can see where people are thinking, okay, I'm not 100% sure. I can understand all that, but when I get down to these last two, what happens? Okay, well, it's very simple. First of all, if you know you're going to end up with a 3 or a 2, in other words, if you're going to end up with an odd, you're going to have a 1 as your very last one. Okay? So even if you think you get down to 1 minus 1, it's 0. Do I put a 0? No, you put a 1 because you got an odd. You have to put a 1. Okay, when you get down here and your second last one, it'll usually happen on your second last one. You get 2 minus 2 and you get 0. You put your 1 because that's what you're meant to do. If the numbers are the same, if it's 3 minus 3, 7 minus 7, if it's either 2 minus 2 or 1 minus 1, a 1 goes in. Okay, a 1 goes in. Whatever it goes in there. And then what are you left with? Well, obviously, you're just left with a 0 because it's even. Okay, that's the beauty of this. That's what you have to do. Okay, right. Suppose that brings us on then to probably the most important part of it, and this is the bit we had a think about when we were doing the logic. Remember, we were doing the adder, the half adder. Okay, so adding numbers. It's as simple as that. adding those two numbers. But first of all, what are those two numbers? Well, let's have a look. Let's do them quickly. Okay, that's 2 to the 0. That's 1. 2 to the 1, 2 to the 2. So that's 9. And this one, 2 to the 0. That's 1. 2 to the 1, 2, and 4. That's 7. So 16 is my answer. Now, I could convert it to 16, but how could I do it very quickly? Remember, what did our half adder say? When you have two ones, it's a 0, carry a 1. Have two ones, it's a 0, carry a 1. Have two ones, it's a 0, carry a 1. Have two ones, it's a 0, carry a 1. That's 16. How do I know? That's 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. What the hell is 2 to the 4? 2 to the power 4 is 16. Bing, bing, boom. You see how it works? And this works beautifully because of that half adder logic. Remember the exclusive or and the and, I think it was? And the not, there was a not and an and joining the two of them. Yeah. So it works amazingly quickly. So our last bit is, well, what happens if you have extra? So for example, if I add 1 1 0 1 0 0 0 1 and 1 0 0 1 0 1 0 0, well, let's add them. Okay, 1 plus 0 is 0, 1. 0 plus 0 is 0. 1 plus 0 is 1, 0. That's going to be a 0 and carrier 1. Okay, that's going to be a 1. That's going to be a 1. And 1 plus 1 is 0 and carrier 1. But wait a second. We've got a 9-bit. We had two 8-bits. And now we suddenly have a 9-bit. A 9-bit number is not going to be got from adding two 8-bit numbers. The maximum you can get from adding two 8-bit numbers is 510, I think, or something like that. You know, that's going to be a bit bigger than that. So what happens is the computer chooses to ignore this one and go with that. The problem is that's not going to give you the answer you've got. And this is what's called an overflow error. Okay, the CPU is expecting an 8-bit. Okay, and you know, you've got a problem. Now, computers usually deal with this extra bit by storing them somewhere else, and flags are then used to try and figure out what's gone wrong. Okay, now you don't know what this is happening, but it can lead to a loss of data, obviously, and a loss of accuracy in your answer, big time. It could also crash the software if you don't have a way of dealing with the extra bit that's happening. Okay, which is why you have multi-threads, and which is why you have complicated kind of algorithmic processes within the actual CPU that will deal with this extra one and allow you to do it. That's where you get your 32, your 64 bits coming into play. That's where you get your hex coming into play, stuff like that, to get over this kind of idea, for want of a better word. Okay, right, thank you very much.